Imagine driving across a bridge and looking straight down more than 600 meters. That's the height of the road above the Beipan River in China's Huajiang Grand Canyon. This isn't a concept, it's a real highway bridge. At 625 meters above the river, the Huajiang Grand Canyon Bridge is now the world's highest bridge, with a main span of 1,420 meters. But the unbelievable part isn't just the height. Engineers had to build it across one of China's most difficult mountain landscapes, with enormous steel sections, extreme canyon winds, and almost no room for error. So how do you actually build a highway in a place like this?
The Huajiang Grand Canyon cuts through the mountains of Guizhou in southwest China. For people living on opposite sides of the canyon, crossing the terrain used to mean following a long, winding mountain route. The new bridge changed that completely. When it opened to traffic in September 2025, the crossing time between the two sides fell from roughly 2 hours to about 2 minutes. But getting a road across the canyon wasn't as simple as putting a bridge between 2 points. The bridge had to carry highway traffic across a huge vertical drop. And the higher the engineers went, the more difficult the environment became. This was a bridge where the construction site itself was hundreds of meters above the river.
All clear on Catwalk 7.
Guizhou is
Catwalk
dominated
7.
by rugged, mountainous terrain. The province has become famous for extreme bridge construction because roads often have to cross deep valleys, steep slopes, and complex geological terrain. In fact, nearly half of the world's 100 highest bridges are located in Guizhou. But Huajiang presented a different level of difficulty. The final bridge would stretch 2,890 meters across the canyon. Its main suspension span alone would measure 1,420 meters, and the road deck would sit 625 meters above the river. That meant the engineers weren't simply building a bridge, they were creating a massive structural system between two mountains. And every component had to arrive at the right position, at the right height, under the right conditions.
The first major challenge was creating the structures that would support the suspension system. The bridge's towers rise from opposite sides of the canyon. But this wasn't an ordinary construction site. Workers were operating at extreme elevation while dealing with powerful winds moving through the canyon. Reports from the project describe winds sometimes exceeding force 12 on the Beaufort scale during construction. That creates a serious problem. When you're lifting hundreds of tons of steel, hundreds of meters above a river, even small movements matter. So the construction team developed heavy-duty climbing scaffolding specifically for the conditions. And they also used a smart cable hoisting system that incorporated China's Beidou satellite positioning system. The system was designed to position heavy steel components with millimeter-level precision. Because at this scale, being slightly wrong at one end can become a much bigger problem when the structure has to meet in the middle. Once the towers and supporting systems were in place, the bridge needed its most important structural element: the main suspension cables. These cables carry enormous forces from the roadway and transfer them into the towers and anchor systems. And the scale is difficult to comprehend. Each of the bridge's two main cables contains nearly 40,000 individual steel wires. Each wire is only about 5.7 millimeters in diameter. Put all the wires from both main cables end to end, and their combined length would be enough to circle the Earth roughly twice. Thousands of thin steel wires working together to support a highway suspended hundreds of meters above a river. But the cables were only part of the challenge. The roadway still had to be built, and that meant moving enormous steel sections into the canyon.
The bridge's main roadway structure uses a massive steel truss system. The central structure was assembled from 93 sections. Some of those steel sections weighed up to approximately 215 tons. Imagine a piece of steel heavier than many fully loaded commercial aircraft, being lifted into position high above a canyon. That was the job facing the construction crews. The smart hoisting system was developed specifically to handle these extreme lifts. Instead of simply relying on a crane operator's visual judgment, positioning technology helped engineers control the location of the suspended components. The goal was simple: get each enormous section into exactly the right position, then connect it to the structure already in place. And this had to happen repeatedly, section after section, until the two sides eventually met.
But there was another enemy: wind. A canyon can behave very differently from an open plain. Air is forced through narrow spaces, and the terrain can create powerful and unpredictable wind conditions. For the workers, this affected almost everything: lifting steel, working on scaffolding, positioning components, and even welding. Strong winds can interfere with welding quality by affecting the molten weld pool and increasing the risk of defects. So the construction team developed a windproof welding technology for the project. The bridge also required extensive wind resistance engineering because the completed structure would remain exposed to the same environment for decades. The engineers weren't just asking, can we build the bridge? They had to ask, can the bridge remain stable when nature starts pushing back? A suspension bridge this large cannot simply be made rigid. It has to respond to forces such as wind and traffic while remaining within safe limits. That meant wind resistance became a major part of the design. Engineers used wind-related monitoring and testing to understand how the structure would behave. Later reporting on the completed bridge described the use of Doppler laser wind radar, wind tunnel testing, and stabilizing panels designed to help manage turbulent gusts. This is one of the most important ideas behind massive bridges. Strength isn't the only goal. The structure also has to be able to move in a controlled way. Because when you're building a bridge nearly 2 kilometers across, trying to stop every movement can actually create new problems. The goal is controlled behavior. After years of construction, the bridge reached its defining moment. The steel structure was brought together across the canyon. By January 2025, all 93 sections of the main structure had been assembled, marking a major milestone toward completion. Then came the final systems: the roadway, safety infrastructure, inspection, testing, and monitoring. Because before thousands of vehicles could cross this bridge, engineers needed to prove that their calculations matched reality. In August 2025, the bridge underwent a major load test before opening. A fleet of 96 trucks was used during the testing process to evaluate how the structure behaved under controlled loading. For an ordinary bridge, this might already sound impressive. But this bridge was about to carry traffic 625 meters above a river. Every measurement mattered. Engineers monitored how the bridge responded to the load, how much it moved, and whether its actual behavior matched what the design predicted. The test passed, and the bridge was ready. On September 28, 2025, the Huajiang Grand Canyon Bridge opened to traffic. The final numbers are staggering. 2,890 meters long, 1,420-meter main span, 625 meters above the Beipan River, and a crossing that once took roughly 2 hours could now take about 2 minutes. The bridge also became the world's highest bridge. In April 2026, Guinness World Records confirmed its height at 626.01 meters after repeated measurements and verification. But the record isn't really the most important part. The bridge changed what was possible in this landscape.
The Huajiang Project is part of a much larger transportation network. Its purpose isn't simply to create a world record.
It connects communities across difficult mountainous terrain and makes travel through the region dramatically faster. And the bridge has also become part of a tourism development project. Viewing areas, walkways, and other attractions were integrated around the structure. Since opening, the bridge has attracted visitors while creating new opportunities for surrounding communities. So what started as a transportation problem became an engineering project and eventually became a new landmark.
Look at the bridge again. From the ground, it almost looks impossible. But nothing about it happened in one giant leap. It was built through thousands of smaller decisions. Where to place the towers, how to control the cables, how to lift hundreds of tons of steel, how to measure every component, how to deal with canyon winds, how to test the finished structure, and finally, how to turn two sides of a massive canyon into one road. That is what extreme engineering really looks like. Not defeating the mountain, but understanding its forces and designing around them. The next time you see a road crossing a seemingly impossible landscape, remember that you're looking at the final result of thousands of engineering decisions. Thanks for watching. Please like and subscribe to Beyond Manufacturing for more incredible engineering stories from around the world.